please introduce yourself and Zero Z and explain its core mission?
I'm Michael, the co-founder and CEO of Zero G. At Zero G, we're building the fastest and largest AI layer 1. So basically building the technology to make AI safe, transparent, verifiable, and then also community owned. And we're the largest in terms of the ecosystem that we've built, more than 300 projects building on top of us. With Foundation and Labs, we've raised more than 350 million in financing. And we've also done a lot of innovation on the technology and research side. For example, we were the first to train 107 billion parameter model fully decentralized. People didn't think it was possible, and there's also 3x the previous record. And so consistently pushing the envelope. My personal background, I started in technology at Microsoft and SAP Labs as an engineer and technical product manager. Then I worked on the business side. I worked for Bain & Company. I worked for Bridgewater Associates, the world's largest hedge fund. After that, I went back to graduate school at Stanford. And at Stanford, I started my first Y Combinator-backed unicorn company on the Web 2 side. I ran that for a number of years. And then early sort of May 2023, I started Zero G because I met with Ming and Fan, connected through my former classmate Thomas, and came to the conclusion that they're the best engineers I've ever worked with, and we had to start something together. And that's kind of how Zero G was born. Yeah, thank you.
So Zero G is known as the world's first modular AI blockchain. What is the specific reason for adopting a modular architecture with a focus on the field?
So modularity, the benefit is that you can take different components and create a system that's exactly good for your specifications. So I'll give an example. If you have a statue and it's one block, and then you just chisel away at the statue, then the statue is just one block and you can't really make many changes to it. But imagine if you have the same statue and it's all Lego blocks instead. You can still take some Lego blocks out and put new ones in. And so modular architecture enables you to do that. And because of the modular architecture, we were able to create a system that's in effect infinitely scalable. So you can build whatever application that you can build in Web 2 fully on Web 3. And AI in particular happens to be really extreme from a resource demand standpoint. And so for that, we needed to build it in a modular way so we could enable the throughput that's required.
So modularity and AI has synergy?
Absolutely, because for example, we have multiple networks. So we have a network where you can write your application, write a smart contract, that's the layer 1. Then we have a storage network because you need to store your data somewhere, like the training data for the model, an agent's memories, like your files, they need to go somewhere. Then you have a compute network because you need to actually interact with AI agents or ask questions to the model. So that's inference. You have fine-tuning, you have pre-training as well as part of that. And so you can use these systems all together, or you can use one at a time. So you could be on a different blockchain, but still use our storage network. And it creates a way for you to figure out this application, I really need to do it a little bit differently, but I still want to use Zero G storage network. And so, for example, you could even utilize an open source model, store it on Zero G, but then have it be queried by a Web 2 service. And so that enables for a lot of customizability. Yeah.
People easily can think of like modularity has very efficient, but you said you made a model with 10 billion.
107 billion.
107 billion.
Yeah. Yeah.
So how was it possible?
It's so we took some of the initial research that was done by Google, initially called DLOCO, and then we enhanced the research by parallelizing the communication effectively. And so by doing that simple, it's not simple in research, it's like very complicated, but by doing that step, we were able to create a 357x improvement over the previous communication kind of requirements. And we also solved things like gridlocks on the system. So one node may be waiting on another node for data and it's not doing anything. And so instead we parallelized the process. And so that led to really breakthrough results. And so we called the paper DLOCO X for like basically the speed up. And so that's how we were able to do that. Yeah, yeah.
So could you explain how there is sense model and how this technology enables the realization of this?
Absolutely. So the multi-consensus model right now primarily is used for data throughput. So if you look at a modern AI data center and you're trying to train a model, you generally need throughputs of hundreds of gigabytes, even a terabyte per second. When we started, Ethereum as a blockchain did about 80 kilobytes per second in throughput. So you're a million times off from where you need to be. And so we needed to figure out an architecture that can scale to these AI workloads and had to completely re-architect how things work. And so again, we used this aspect of parallelization. First, we split data into a data storage and into data publishing lane. And that enabled the network to utilize all of the nodes throughput. And so then you can use thousands of nodes to get to a throughput of maybe around 50 gigabytes per second. Eventually, the consensus layer becomes the bottleneck because it can't handle more communication with those nodes. And so what we can then do is instead of improving a consensus, we can just spin up a new consensus that can interact with even more nodes. And so in effect, it's similar to if you are on Amazon Web Services and you need more throughput, you just spin up a new machine. So it's horizontal scalability. So we can do the same thing. We can spin up new consensus layers so you can infinitely scale the data throughput. So it's not just the 50 gigabytes per second, but it can be terabytes per second, even more in the future. Whatever demand there is for an AI application, we can now meet with the system. So that's why infinite scalability.
In that way, so your chain can handle the points of the data.
Absolutely. It's built for AI specifically for that purpose. No other chain is able to do this.
And the concept intelligence NFT of Zero-G is quite interesting.
Yeah.
So what needs do INFTs address and what advantages do they offer?
Yeah, so the key question we asked ourselves is, how do I know who owns my AI agent? And it's a complicated question because if you go on to, for example, OpenAI and you create an agent, you have to read the terms and conditions of who the agent belongs to. Let's say one day it belongs to you, they change the terms and conditions, and then it belongs to OpenAI all of a sudden. And so that ownership is centralized. So that's a key issue. But what we wanted is we wanted to definitively say that if I own an agent, I want to own it outright. Nobody can take that ownership away from me. So we came up with this interesting concept of a new form of NFT called the INFT, or Intelligent NFT, ERC 7857, where we embed the private keys of the agent into the NFT. And then when that INFT is in my wallet, I can say that agent now belongs to me. And so there's a platform on our chain launching called AIverse. You can create new agents, and they're an INFT. So anything the agent does, like, for example, if it's a trading agent and they make some profit, it belongs to me now. And then I can trade that ownership with somebody else. This was never possible before, because even platforms like Virtuals are centralized ownership. The platform can take the ownership of the agent away from you. In this case, that cannot happen. It now belongs fully to you.
INFT is like kind of ownership of the AI agents.
Correct.
On the Zero-G.
Only on Zero-G right now, yes.
Then you have the platform for AI agents.
We do as well, yeah. So AIverse is that version of the platform. And so that'll be available from day one on our public mainnet.
And could you please describe the working principle of random access as it's used in Zero-G's centralized storage system?
Absolutely. So this is a very important concept because if you have your own storage on your laptop, you always have it accessible to you. You know exactly when it's on, it's in front of you, you can store things on it. But now all of a sudden, when it's a decentralized network and you have different nodes across the world and you don't know if they're on or not, how do I know that my data is safe? And so we need some verification mechanism. And that verification mechanism is called proof of random access, or PORA, as you mentioned. So basically at a random time during the day, that server gets pinged. And if it doesn't meet the window and says like, oh, I'm still on, I still have your data, then it won't get the reward. And so it's a rewards-based system. It's an incentive-based system for people to keep storing your data. And what we also do is we make sure that the data is not just on one server because that's too unreliable. We need to split it into multiple servers. So you have like a backup capability right from day one. And then those servers consistently have to meet the proof of random access windows. And so it ensures that when you give your data to the distributed network, that it's always available for you. Yeah.
So Zero-G has all the things for the AI.
Absolutely. And in fact, that storage network is designed by my co-founder's research paper. So he worked at Microsoft Research for 11 years, and he wrote two very important papers in the distributed storage space called Tango and Curfew. So the storage model is based on those two papers, and it's very flexible. It can be cold storage. So if you just want to move some data there that you don't access very often, you can do that. And it has hot forms of storage as well. So if you need something, even transactional storage, for example, if you use some Google products like Google, like the Word version, Google Docs, you consistently need to have very quick access to your data. So that network even supports that, fully decentralized. And so it enables those data types, and also it's designed for very fast upload and download speed. Pretty much most other storage networks in the space were not designed for AI workloads. So often the upload and download is very slow, but that can't happen generally for training purposes or for inference purposes. It needs to be really fast. So it needs to be in the gigabytes per second again.
So all the kind of infrastructure is really close relationship with AI, centered AI.
Correct. Correct, yeah. Because we believe if we solve for this extreme use case, you can solve for all the other use cases as well. And AI happens to be the most intense, resource-intense use case. Yeah.
The zero-G token is really a hot issue in Korea, of course. So could you please explain the tokenomic structures for utilities of the token, the native token?
Yeah, we love our Korean community, by the way. So I feel like Korea is my second home now. This year I must have been here at least every month once, and so it's been a lot of fun. It's been great investing in the local ecosystem, and we have the biggest deal ever with KBW, for example. We signed a 3-year partnership because that's our commitment to being local, working with builders, working with media, working with kind of investors and retail audiences as well. We have local team members. We have investors like Samsung Next, for example, Nance Capital, Leica Ventures. They're all part of the ecosystem. So we love being here. And so I just wanted to mention that as well. But from a tokenomics perspective, Zero-G has multiple utilities. So there's the standard providing security. So staking and even restaking will be supported, and even liquid staking will be supported on the mainnet. So that's the security layer. There's a governance layer. So in order to participate in, let's say, voting or vetoing, you have to have Zero-G. And then all the infrastructure pieces that I mentioned, like storage and compute and gas costs and the different applications, they will all consume Zero-G. And so you can then utilize all of these aspects of the Zero-G chain with the Zero-G token. And so there's significant utility from the applications. And every time there'll be a new application, it'll generally have some positive impact on the economics.
That was my last question. I wanted to ask you about the Korean.
Oh, I see. I already answered. I preempted your question.
And before the TGE, do you have anything to show off, like performance of your testnet, data figures to share with us?
There's quite a lot that we've done. So you already mentioned the INFT. I mentioned the training. So nobody's been able to do that before, the 107 billion parameter model. There's many other research points that I won't go in for now, but the testnet itself has shown that we can have, so it's fully EVM compatible as a chain, and we have a sharded approach. So in effect, it's infinite scalability on data throughput and transactions per second. But each shard we've shown can do 11,000 transactions per second at a block producing time of about 400 milliseconds. And so that's the blink of an eye, basically. And for Ethereum, it takes, I think, 13 minutes or something for block time. So it's a significant advancement in blockchain-based technology. And on the testnet, we had hundreds of millions of transactions. We had 24 million, I think even more than that, maybe wallets or so. So it's stress tested the network a little bit. Yeah.
Did Korean users also skate in your testnet?
Yeah, absolutely. So we had a number of influencers work with us, a number of retail users testing the testnet. In fact, we had a very successful node sale that sold almost 100,000 nodes. And we believe 20 to 30% were from Korean users as well. So very large percentage participation. Yeah. Yeah.
Do you have any roadmap for the Korean market?
So the key thing for us is to invest in multiple avenues. So there's, of course, the whole sponsorship around KBW and the media sponsorship. Then there's going to be some activations on the builder side, so working with local universities, doing hackathons, and so on. And then doing more kind of influencer engagement and marketing as well locally. So those are the three areas that we're looking into specifically. Yeah.
Finally, we already checked your affection for the Korean users, but do you have any message to share with the Korean users?
Well, we're particularly excited because we see ourselves as the leader in decentralized AI on the technology side, the ecosystem side, the research side, and the funding side. And so we're very excited of working together with Korean institutions and users to consistently build upon that leadership and to make our mission of making AI a public good a dream come true. So we're very excited about our community. We love our Korean community. So thank you for being with us.
They will like it. So thank you for the time for the interview. So that was really good.
Oh, thank you. Yeah, that was a lot of fun. Great questions. Thank you.